out, you have to multiply here that, right? So basically taking this thing inside of this integration, right? That's what you mean, I believe.
Yeah.
So yeah, so it gives you alpha minus beta and multiply e to the power beta t inside of that.
It is alpha t.
Yeah, so the first term becomes like integration t0 up to t f at t prime e to the power negative alpha t prime dt prime. Then you have multiplied by e to the power alpha t only, right?
Yeah. Yeah. And in the other side only it is our beta t.
Yeah, and then on the other side you have e to the power. Let's take that thing inside of the integration as well. So t0 up to t e to the power beta t e to the power negative beta t prime f at t prime dt prime.
Yeah.
So for one part we have okay. I think it's 1 over alpha minus beta. So it gives like integration t0 up to t f at t prime e to the power alpha t minus t prime and then negative integration t0 up to t f at t prime e to the power beta t minus t prime.
Yeah.
Okay. It has started to look good. So we can do actually one more thing. We can write it as single integration t0 up to t f at t prime then e to the power alpha t minus t prime minus e to the power beta t minus t prime, right?
Yeah.
And actually I want to take 1 minus alpha beta inside of it, so erase there and divide it by alpha minus beta. That singularity is now contained.
And we can also okay, yeah.
This is the most simple possible thing here. So now we are done we are done with that partial fractions, like integration by parts. So now we need to substitute, right? But I forgot like where we started and where we substitute. Okay, so here actually we need to substitute, right? This term.
Yeah.
Okay. Also, yeah, this is all. So let's substitute. Oh, before substituting that,
we can make it.
What happens like? Yeah, what happens if we like substitute these two things as well?
We can make alpha and just put the value of alpha and beta and e to the power gamma t outside of the integral.
Okay, let's write everything out now. Then we'll see what's going on really. So now we have x e to the power beta t minus t naught. That's we had previously. Then also this part, but for here we have to substitute whenever we see a t double prime. We have to substitute for t and t0. So for upper limit and for lower limit we have two different results, right? So plus oops, we have to write two different things. So what can be factored out? So v minus beta big X, this can be factored out, divided by alpha minus beta can be factored out, and then oh no, alpha minus beta cannot be factored out. Oh, actually it's a multiplication, right? So yeah, it can factor out everything. So e to the power negative alpha t naught e to the power beta t, this also can be factored out from that final result. Now we have just two terms. One is e to the power alpha minus beta into t minus e to the power alpha minus beta t0, right? This is upper and lower, substituting by upper and lower limit. Is that okay?
Yeah, I think if you
simplifies
put the value of alpha and beta, it can be more simple.
Yeah, if when we substitute alpha and beta explicitly, then it becomes more simple. So yeah, for now, like let it be like this, and also the last term plus the last term is what we got here, 1 over m 1 over m integration t0 up to t0 up to t. What else? F of t prime, f of t prime multiplied by this whole thing. What's that whole thing? E to the power alpha t minus t prime to the power alpha t minus t prime minus e to the power beta t minus t prime. Okay. E to the power beta t minus t prime dt prime.
Yeah, now you can leave this as an exercise.
No. We were actually almost done. We are almost done. So what we need actually, few results. What is alpha minus beta? What's that? So remember, alpha
Just
was
imaginary.
negative I gamma. Sorry, negative
2i,
gamma.
2i capital omega. Yeah, 2i omega, alpha minus beta.
Yes. So alpha minus beta is nothing but twice I omega, where we know what's the definition of omega is, right? So that's our alpha minus beta. Also, what is e to the power alpha something, like alpha t star, this, let's say t minus t prime is t star, minus e to the power beta t minus t star. We also need that, right?
Yeah. E to the power minus gamma t prime. We can
Okay, so
take common, and for the rest,
so yeah,
there should be a sign.
Let's
Sign
substitute.
function.
Substitute. If we substitute that, it's alpha is nothing but negative gamma plus I omega, then t star, minus e to the power negative gamma negative I omega multiplied by t star. So from these two things, we can actually factor out e to the power negative gamma t star, and then we have e to the power I omega t star minus e to the power minus I omega t star. Does it look any like familiar?
Sine function.
It's a sine function. So we divide this thing by twice I.
Twice sine function.
We multiply this thing by twice I.
There is a alpha minus beta. So
also there is alpha minus beta on the bottom. Okay. So what is alpha minus beta?
2i omega, and which will provide
it is
2i.
So
already 2i omega, so we need not to add that, right? So due to that alpha minus beta, we are actually a little bit lucky. So it has become 1 over omega e to the power negative gamma t star, and then this thing becomes sine big omega t star.
Yeah.
So now we are ready to substitute everything, right?
Same function.
Yes, same thing we got previously. So x. Also we need to factor out this crappy thing later. We'll do that thing later. So beta t minus t naught. Also here, plus v minus beta x e to the power negative alpha t0 e to the power beta t, and then we have like e to the power alpha minus beta t. What's that? And divided by alpha minus beta. So what's that? It's 1 over omega. It's 1 over omega sine big omega t, right? Hello, is it correct or not?
Yeah. I think it's not correct.
Why?
Uh,
Oh, we had T naught,
yeah.
right?
Yeah, T naught.
Okay. Okay. Now we have to take care of that thing as well. So what you can write is,
we should leave it as it is.
Actually, yeah. For now, just leave it as it is. Yeah. Actually, we should multiply this thing inside of that integration. That would simplify. Otherwise, not. Anyway.
Yeah, we can multiply to the power minus alpha.
Okay, let's do that in the next step, not now. T0 up to t, f at t prime, and then this whole thing has become 1 over omega e to the power negative gamma. What is t star here? Like it is t minus t prime, right? And then sine big omega t star means t minus t prime dt prime, right?
Yeah.
Okay. So does it look familiar at this stage?
Yeah.
Isn't we had previously? But we have now a bunch of terms here. So let's see what happens. Yeah, those are, but that was also a general solution. This is also a general solution, but why they're different? Okay, we'll see that later, like in a moment. We are almost done actually. Let's substitute and see what happens. Multiply this thing inside and tell me the result actually. I'm bad at algebra, so I'm pretty much sure if I do it by myself, I'll screw something up. Yeah, tell me what happens if we multiply this thing inside. Multiply T naught inside. So e to the power alpha something, that's you want to factor out. So for the first part, you get e to the power alpha t minus t naught. Oops. Right? And for beta part, it vanishes, right?
Yeah.
Like it becomes one, like this thing and that thing. Also, if you take this whole thing again inside of that e to the power, then what do we get? E to the power. Now we have positive alpha t naught. Here we had negative alpha t naught, that vanishes. But we have now e to the power positive beta t and e to the power negative beta t naught, and that remains there, right? So if you want to write t minus t naught, then it's just beta t minus t naught.
Yeah.
Okay. And then we have our,
there is alpha minus beta.
Yes, I noticed that we need to substitute instead of that. So I'm just trying to write the next term, that's all. So f of t prime 1 over big omega.
There is a 1 by alpha minus beta in the second term.
Where? Oh, I missed something. I missed something. There was here like alpha minus beta, right?
Yeah.
Okay, so there should be alpha minus beta as well.
Yes. Yes.
And that gives us the sign again.
Yeah.
Exactly. So if at t prime 1 over omega e to the power minus gamma t minus t prime sine omega t minus t prime dt prime, like that. So for the last part, we get here, if we can if we can factor out like our e to the power gamma, like e to the power gamma, negative gamma, right? So we have x e to the power beta t minus t naught plus v minus beta big X. Then what do we have here?
E to the power minus gamma t minus t naught into
E to the power negative gamma t minus t naught
times such a sine big omega t minus t naught.
Sine big omega
T minus t naught.
Minus t naught
divided by gamma.
Divided by
Big
gamma.
omega. Big omega.
Big omega. Yeah, right. Divided by big omega. Okay, finally we have our result. Yes, this is the final result actually. So I want to write like this instead of, I want to write integration t0 up to t if at t prime, then 1 over m omega e to the power negative gamma t minus t prime sine omega t minus t prime dt prime, right? So do we see what happens when t goes to negative infinity? What happens? What happens when t naught goes to negative infinity?
Oh, yeah, the boundary terms vanishes.
Yes, when t naught goes to negative infinity, substitute that over here, right?
Yeah.
And you can actually factor out negative gamma inside of that. Actually, this whole thing has like this term, e to the power negative gamma t minus t naught, which goes to 0. So when you let your lower limit to be negative infinity, then this term vanishes. So, and what do we get in that specific limit? We get negative infinity to t. If
exactly what?
Exactly what we expect. Expected from the previous result, right? What you got from the previous part.
Yeah.
So basically, as I claimed, that boundary term actually can be absorbed by that green function integral. Now we can see it explicitly. And it also makes sense because boundary terms is actually telling that what's the initial velocity and initial position at t equals to t naught. But that initial velocity at t equals to t naught or initial position at t equals to t naught, that's a consequence of that, all the history that have been going on over the course of time. Like you have been pushing a little bit every time, and you're contributing to that x naught and v, big X and v. That's what we got from here. So finally, we learned something from here, that a linear differential equation can be solved by a green function procedure, and that exactly produces the correct result when we do explicit integrals as well. And also, it respects the causality. That's the important part.
Yeah.
Because our current result of position, like this is the result of x at t, that's a result of like all the forces you have applied before this time, before this t time, that's the result x of t is.
Yeah.
So yeah, that was all for oscillation. Now we will dive into Lagrangian mechanics. We are done with this part. It took a lot more time than I expected, and it happens every year. It's nothing new. So do you have any question you can ask? Let's have a break time, up to, like, in my time, in real time, it's 10:24 a.m. So let's take it up to 10:35 a.m. And during this time, you can ask any question if you want. I'm here.
What happened at t not equal to minus infinity? That information is vanished, right?
Which information is vanished?
What happened at t equal to t not equal to, when t not equal to negative infinity?
No. So at negative infinity, by definition of infinity, like, there wasn't any position or momentum to that particle. There was nothing. So you're thinking like probably